All right, so a quick backstory. 5 months ago, a client approached me for a project. At the first glance, the project seems to be very easy, but as I broke the requirements into sub requirements, the complexity just went too large. And I was also waiting for this kind of project because I was literally fed up of making just APIs calling from the front end and catching from the back end and just doing the typical things. I literally want to do something other than CRED. So luckily, I found a client. Before starting, let me give you a little bit of context that this is not a tutorial or a demo video. This is just a raw talk between software engineers, like how we break problems. And if you're looking for a project that you are literally bored from just making the CRED APIs, this is the go-to video. You can watch it, and we can have a talk. We will be solving a real world problem. Uh, Literally, it's a big problem, and if you can solve it, it can literally shine on your resume as well. So this is a raw talk. I even got my cup of coffee. I will be enjoying that. Hope so you will. So let's start. First of all, let me show you what will you actually be understanding at the end of the video. Okay. So this is what we want to build. Okay. So basically, we are building a scalable distributed scrapping platform. Okay. The name is kind of difficult and literally it looks like wow, what is this? But literally, I'll try to explain this and I'll try to break this into small portions. Okay, then you can understand it better. And this is the industry grade application, and we will be going through how we're building this. There are literally too many solutions for a single problem. The main thing is to select the most efficient one, so we will be looking for that. And then at the end, we will be also looking into how we deploy things, okay, using GitHub Actions, what are CI/CD pipelines, and how to set up things like A to Z, from writing one line of code to your code in production and helping the client. All right, so this is kind of that project. So let's start with the requirements that client passed me on that day. That it was, they want to scrap some data. Okay, so this is a demo website that I can show you, like how scrapping works and what is basically scrapping. Scrapping, in very easy words, is just there is a data on some website. Okay, you just have to go to that website, get that data and save into your database, or you have to do any operation. And yes, it's legal. Okay, so we will be checking that aspect also, that how it is legal and where it is not legal. Okay, so we have both aspects, but this is basically a website that I can show you. So you can come here. This is the URL that you can also find in the description of the video as well. It's books to scrap. We love being scrapped. This is simple HTML page, but let me show you one thing. All right, so some of the products are listed on the website. I can't show you the client's project, the client's specific details, because obviously it is confidential, but I will try to make sure that these things align with the client requirement as well. Okay, so what we need, we want to scrap this all data, and at the end of the day, I have will be having a database row of a book like the Black Maria, this one, and its price, and if is it in stock or not, and this opens to the other page. And I also want this detail as well, not only this one, but also this. I want the product description and all the information. All right, so this is what we call scrapping. And scrapping can be used for many purposes. Okay, so the purpose for my client was to, we have to train a model. Okay, so we need data, and then we train the model on that data, and we going to do some stuff with the data, with the model as well. We will also explain that. We have literally an AI part proper, if I can show you here. So we will be also looking that also. All right, so seems very easy. We can use some web scraping libraries in any programming language to scrap this page. But now let me raise the bar. Let me tell you the problems. The thing is this, there are maybe like 50 pages, or you can say, if I just do a simple calculation, there may be 1,000 books. maybe 1,000 books. So at the end of the day, you are scrapping 1,000 pages, and that's all. You can scrap with any library. For Python, you can use just request and then parse and crawl and everything. That seems very easy. But let me tell you one thing. We are not talking about hundreds, thousands. We are talking about millions. Just imagine these books, which are literally thousands also only. But just imagine there are 100 million books, and you want to scrap each book. This is the point where things goes out of your hand. Like that, I have to scrap 10 thousands, millions, 10 millions of book, and we have limited resources. Okay, we are not being sponsored by the top tech companies, so we have like the limited resources, and we have to scrap. So one thing that is clear right now, that we can't use the synchronous approach. These are not a research, just my experience, that if you uh, scrap website one page, and using synchronous approach, the typical approach, it roughly takes 30 to 40 seconds. Here you go. 30 to 40 seconds for a single scrapping of a page. But this is not how scrapping works. Oh, let's continue this later, but let's talk about this aspect. 30 to 40 seconds for single page. Now multiply this with 1 million pages, 10 million pages, or maybe 100 million pages. Your maths will be disturbed here. You can't. So this is the thing. We can't use a synchronous approach. We can't be like doing some typical things and placing the URLs of the product into our code, and then the libraries do this magic, and after 40 seconds, what's in our database? A single row. And that's not the thing. We have to implement a solution so that every day we can at least scrap 100k pages in like hour, multiply that with 24. We're talking about the scale. We're talking about millions of things. When the technologies like Facebook get, they are built to cater millions and billions of the user. So we will also looking to like cater millions of the pages. And let me tell you one more thing. If you run this project that I have created and give me unlimited resources, this project can scrap the whole internet in 5 days. So this is the amount of the websites that are currently live on the World Wide Web. 1.34 billion websites. So this is what we're trying to build. This is the problem that we're trying to solve. Okay. So basically, this is the kind of the page that you mostly see on most of the websites. So you have a URL, and there are multiple products that are listed. We want this data also, but we want the, you can say, specific data of the website also. Like for example, set me free has this amount of rating, price, and it's in stock. That's all. This is what we got on the listing page. But come here, product description, product information, and all. So let's create. First of all, I'm pretty sure that I have make you understand that you can't use asynchronous approach here. So we will be dealing with the asynchronous approaches, distributed task queues, and how scaling works. What is horizontal scaling? What is vertical scaling? This is the amount of the things that we are going to do now. All right. So let's come here, and I'll explain you very simply how the scrapping actually works. This, all right. So scrapping consists of many subsystems. Okay. So one thing that initially comes to our mind that we can use any programming language to do scrapping. For example, we are using Python because I have also developed this project in Python as well. Okay, so first of all, we need a scrapper that scraps the data. But let me tell you one thing: what will be scrapper doing initially? No hype of words, very easily. I'll pass a URL to it. For example, I'm passing this URL to my scrapper. Go scrapper and scrap this website. What will happen here? Let me tell you. What will happen? This page will be opened in the library. I'm taking things very clearly and easy. Okay. This page will be opened in my library. The whole HTML code of this website will be copied to my code to my basically programming language. This all code you can see. Okay, all right. So if you want to see the HTML and CSS of any web page, you can simply press Ctrl plus U, and many browsers will open their source code. This source code will be copied on my system locally, and then we're gonna do some processing. For example, I'm scrapping this book named as Set Me Free. So if I go to source and if I search here free, this is the article that you got. It's a div that have an image. Okay, this is, you can say, the source of the image. All right, and all other detail is also available here. So this is initially how things work. What we are doing, we are passing the URL to our scrapper goes to that site simply, and it copies the HTML, and then we're gonna do some processing on the HTML. Not only we are going to scrap the data, not we are going to just fetch the data and save into our database. That's a very easy operation. But let me tell you one thing: should I give new URLs every time? Should I pass this URL? Then should I pass the URL for travel, then for mystery, then for historical fiction, and then for classics and so on? This is not possible. We just want to give a single URL. This is here where another things come in, that is known as crawling. Crawling, just like a baby crawls from one place to another. This is a crawler. All right. So let me. What's the main purpose of the crawler? Crawler's only purpose is to find the URLs from the HTML pages and then send a request on that. So, are you able to see a loop? If not, let me tell you. I'm literally bad with like the diagrams, but I'll make sure. So, what is happening? The scrapper is scrapping some of the web pages, right? It processes their HTML and it passes that HTML to crawler. Crawler tries to find the URL in the HTML and pass that HTML again to scrapper. Sorry, pass that URL again to scrapper. So scrapper starts to scrap that page, and this is the loop. So we solved one problem. That, sir, we just need the first URL, and then we can find other URLs from the page itself. Not making sense. Let me tell you. I opened the source again. For example, I want to read the books that are related to health. Okay, and this is the health URL. Basically, if you can see very closely to my image, to my video, sorry, you can see the URL. If we hover on the URL, it shows. Okay, so it's just something like health underscore 47. So if I search here, health underscore 47, here you go. This is your URL. But should it open when I click on it? Yes, it will. And the URL is being opened. So if I simply go here, this and this URL are the same. So we can find the next URLs from our initial page. This is what I want to tell you. So this is how things work. We just give some URLs to our scrapper, Most of the time these URLs are known as seed URLs. So we give seed URLs to our scrapper. The scrapper downloads the HTML simple words and passes that HTML to crawler and say the crawler, please let me find some other URLs because I'm hungry. What does crawler do? Crawler's only purpose is to find the URLs and pass the URLs again to the scrapper. Making sense? Now another problem arises. What if what if I encounter an URL that is already being scrapped? Thing can be do like na. There is a travel category. Alright, this is the travel category if I can show you here. Alright, this is the travel category. Might be due to some glitch, unintentional or maybe intentional. Again, at the place of history, travel comes again. So we are scrapping multiple times. So here we want a frontier. Frontier can be anything. It can be temporary list, temporary array, or if you are building on scale, it can be your database table. So we need a frontier as well. Getting my point? Now what will happen? Let me tell you. Scrapple will scrap the pages. We will give our initial URL that is here books2scrap.com/index.html. It will pass the full HTML to crawler. Crawler will again find the URLs from that HTML, but before sending to the scrapper, it will go to the frontier. It will say, Frontier, do you have this URL? If Frontier replies true, if it says yes, I have this URL, it means the URL is already visited and we don't want to visit it again. Getting my point? Let's talk about the other scenario. Crawler goes to Frontier. Frontier, that you have this URL of travel, of humor, of parenting, of autobiography. Frontier replies that I don't have this URL. Then we can safely put that URL back to the scrapper. So now we are avoiding the data duplication. We are stopping the crawler to pass the URLs that are already in our frontier or database. Getting my point? So this is how scrapping really works in the systems. Okay. What if scrapping simple website using Python? So if we get some kind of code, that would be easy for us because my project is obviously the client's project. I can't show you, but this is how things work. Okay. Yes, you can use a framework Scrappy and some other projects as well. Right. So explore this. What is happening that there is a class and we have some names, allowed URLs and URLs, just like the basic, you can say the data. And then this is a function that parses. Parse is basically, you can say when you download the HTML, it's in the string format and then you have to parse it because you want to navigate through the HTML tree dot div and then dot heading dot h1, like it's proper structure, a hierarchy. I'm pretty sure that you know this because that's HTML, bro. So this is the ally tag, then the ally tag have a anchor tag. Okay, so this is how things actually work. Let me show you at very start. Okay, so we have a div named as site categories, and then we have another list nav and nav list. Then we have a li, then we have anchor tag. So basically, it's what? It's a tree. Alright. So to navigate through the tree, we need the HTML tree. So we use parsing. So parsing is just converting the string into that HTML tree. So this is the thing that I was talking about, the crawling. This is a list, okay, links, and we are saying soup. Soup is just the parser. Soup find all tr. Tr is just like the table rows. And for this specific website, Y Combinator, maybe the URLs are in the table row. So all links are copied to this list, and for every list, for every link, we are doing some operation. We are fetching the ID, title, URL, and rank. Okay, so this is how things work. Basic uh, Copilot give us also a result. Okay, we are sending the request. Simple. Then we parse the HTML content using the beautiful SOAP. Okay, this is the thing. And then we are extracting all the links. This is where the crawling process is being done. And this is our CD URL. Okay, the target website. So this is actually how things work. You have to do a lot of data processing. I'll be talking about this soon. Okay, why we need data processing? What are the problems? So right now, I hope so that I'm able to explain you how the basic scrapping actually works. But again, this whole process, roughly according to my experience, I'm living in Pakistan, so talking about our internet conditions and everything, this is not any research, not any stats. This whole process is roughly taking around 40 seconds for a single page. So, for example, you are scraping a website, a book named as "The Boys in the Boat." This page needs 40 seconds. Bro, how can you then scrap millions of pages? This is where asynchronous approaches shines, and let me talk about this. What we can do instead of this scrapper crawler and these two functions, because these are our two main functions, we redefine them here: scrap and crawl. Okay, and crawl. These are our two main functions that helps us to, you can say, do everything. And we have a database as well, Frontier, but we will be not talking about this right now. Let me explain you the work here. What we can do, we can simply use a distributed task queue. Simple. What we can do, we can use a distributed task queue. Okay, task queue. Simple. This is what we can do. What are distributed task queue? Nothing. Distributed task queue helps us to do the work in the background. It does not blocks your code. It can say, okay, scrapper, you scrap the novels page, crawler, you crawl the health page. And imagine we have 10 scrappers and 20 crawlers, each working their own work because they are not dependent on each other. They are independent entities. Now, if you know operating system, if you have studied operating system subject, you will be able to understand what I'm talking about. Yes, we will be looking like how to handle the mutual exclusion things, but this is the concurrency. This is how things work. So one more thing that is clear, that do not skip your core computer science subjects. All right. This is distributed task queue. The one that I have used is Celery. It's famous in Python. All right. So this is a distributed task queue, and the workers can't directly talk or communicate with the distributed task queue. All right. They can't. So we need a message broker, right? Just like the property brokers, car brokers. Here we need a result broker, message broker. You can use any, but I prefer Redis. That's quite easy to implement. All right. So Redis sits in between. It's an intermediary between scrap crawl and distributed task queue. All right. And we can make sub queues. One queue is just for the scrapping, and other queue is for the scrolling procedure. All right. So this is how things work. What we can do? We can say we can make another entity named as starter. All right, we can make as started an independent entry. What will be starter doing? Starter will justly pass or put some initial URLs to my scrapping, because scrapping first the scrapping will be done and then crawling. Okay, I have said that the operations are independent, but sometimes like there is a you can say limit. What's the limit? We first need to scrap this and then we will go to the specific page. Make sense? Let me talk. We got the URL of this website, and then these are all the books that are listed here. Set me free book. When we will reach the link of this book, when we will come to this specific page or specific portion of the website, right? So initially I got the name and all thing, like scrapping thing is done. Now the work is of crawler and then again of scrapper. Okay, these are independent, but yes, when we will be finding this, we can save its name to our database. We will be looking this also. Okay, so starter can simply push some initial URLs to this queue, and this worker is listening to this queue or this, and then you can use this type of thing. Cool? Make sense? So it is listening to this queue. The moment you there is some work pending here, this will start executing it. Now what's the benefit of this approach? This is what we were doing. You can say me, oh wait, we are just increasing the overhead. We have introducing the distributed task queue, we have introduced the Redis. Wait. Okay. What this, and this. We're talking about the scale. Now there are four workers of scrap. They will be just listening to this thing, and they are independent. This is something else, this is else, this is else, this is else. They don't know about each other. They are just talking with Redis and the distributed task queue. They do their work and then they pass the result back to the Redis. Make sense? So now scrapping is being done, but what we have created a system that we can increase the number of the scrappers or any other workers. Same goes with the crawler side. And if you think very logically, the scrapper worker is quite less than the crawler. Scrap just scraps the listing pages and then okay. Each listing page consists of the 100 products. The crawler is the one to go to that 100 pages. Make sense? Alright. Again, we have the crawling queue here. The same mechanism can be applied here. It will be attached to this, and this is already attached, and they can do the communication on its own. So this is how production grade web scrapers actually work. All right. So I've explained you can say the basic architecture of how things will work actually. And now let's move to some high level architecture. This is basically described you how can you write functions, or basically how can you write the real logic. Right. So let's come to this main thing, and I'll try to explain you everything. Now a little bit of technical things will come, but this is how things actually work. Okay. This is a system design diagram, and I'll try to explain you whole. Like what is happening, every arrow is literally having a proper, you can say, work that is being done in this project. So focus on this. This is the main, you can say, the block. Okay, this is the user that requests into the system. The first thing in my system is the reverse proxy. Okay, you can search more about the reverse proxies. These are not the in the you can say scope of this video, but reverse proxies are simply is a server that sits in the front of web servers and forward clients requests to these web servers. Okay, so it's basically intermediary. Okay, it knows which request to pass whom. Okay, this is just a thing. For example, let me give you a simple context. Okay, so I have basically a website, right? That website actually have the Nginx running on it. So if I type api.safi.codes, alright, it shows me a message, hi Safi, alright. So this passed the request to another server. Getting my point or not? But if I change the subdomain here to agent.safi.codes, so it's another website. It's literally written in the code that it's under maintenance. Okay, so this passed to another server or another service. So this is what we call reverse proxies. Back to the topic. It's basically intercepting the client requests and forwarding them to appropriate backend. And it can be used as a used in load balancing, caching, and it avoids attack. Your ports are not published, so everything is good. So this is what we call the reverse proxy. Okay, reverse proxy is connected to multiple things, but let's try to explain this very easily. The reverse proxy is linked to my fast API backend. Then you're gonna like, Safi, you haven't discussed the web server. All right, the data you are scraping is storing into your database. No, you want to give the client an endpoint to access the data. This is where fast API or any other server, web server comes in. All right. Request is passed to the client. Sorry, fast API. Fast API is directly connected you to your database. That for this instance, I'm using the Postgres. All right. So this is the thing that this is simply an API read. It can be a read request. It can be a write request. Okay, but I haven't implemented the write request. But you can, if you want to update some product, you can. All right, and then the database can reply you with the, you can say, proper answers, like we have scrapped this much of products in this day, and you can do like the proper CRUD thing. That's completely on you. Then let me explain you this second thing, analytics lookup. The thing that I've already talked, but this is where this is like experts option. Okay, so you can see how many things are scrapped in this day comparison to the last day, how many are new products. Like you can do analytics. For example, I'm scrapping a websites that you can say create that have listed some of the mobiles. So after this much data, after millions of the data, I am having a lot of data. I can do multiple operations. I can tell you that, for example, if this is a listing website, I can tell you how many products, how many mobiles are sold in the New York because I have the data. So this is your analytics, and you can view analytics of your web server also. All right, how many requests and everything. Okay, and we will talk about this later, this thing, but let's move ahead. This is task monitoring. Salary, I was using the I was telling you the distributed task queue. Sometimes you want to view the status of your workers, so you simply do attach your front end, your UI with your message broker. Here it is attached, this. All right, so you can view the status of your tasks that reside in the message broker that is Redis here. That's all. The UI is not connected to anywhere else. It's just connected to this. All right. Let me talk about this thing now. The main thing that we have already told. There is something known as salary scheduler or any scheduler, and to be exact, its name is Beat in Python. Okay, it's nothing, it's just the starter. It's just like a cron tab, a cron job, sorry. What is a cron job? We can say the cron job like every day at 6 am do this, and it will do, and it will do. Getting my point? So we can say at midnight, start the scrapping. B it will initiate a process, and B it will, you can say, trigger this starter. Starter works. What is the job of this starter? Just pass some initial URLs to the scrapping, and that's all. Alright. There are many things that are literally out of the scope of this video. That we are starting the scrapper at every day at 6 a.m. Where to stop? Where to stop? For example, in a listing website, there are mobiles listed on the website, and every day 1,000 mobiles are listed more. Like there is a Redmi to sell, there is iPhone to sell. Okay, what is the condition that comes into your mind to stop the scrapper? All right. So you can implement many things. Like the one I have implemented in the project was that if I encounter more than X amount of pages, if I encounter X number of pages in the page in the website that are already in my frontier, I'll stop scrapping more. Again, if I encounter more than X number of pages in my websites that are already being scrapped in this run of the starter, then I'm going to stop. This entirely depends on your workflow or basically on your problem. Sometimes you want to scrap the full website and then you're okay. Sometimes you have to scrap every day, every hour. This is how things work. All right. So what salary scheduler beat is doing? Just pushing some initial task into my Redis, into the queue. Start working. When these tasks are in my Redis, the workers are listening to it. Here I told you, the scrapper is in the wait. It's looking into the queue. The moment an other task arrives, it will say I'll do it. And then this becomes busy. Then this, then this, then this. So at a single amount of time, how many websites are being scrapped? 4. And increase its concurrency, increase it, make it 100 workers. So at a single amount of time, how many websites are currently scrapped? 100. Getting my point? This is how things work. So the initial tasks are passed to my Redis. Cool. And these are the workers that are waiting for the tasks. And this is the connection between them. Here the workers will pick the task from the Redis and perform the work. XYZ goes to the website, scraps, scrolls, and whatever. And then submit the result back to Redis, whether it's successful or not. And then the workers can store the data into our database. That's entirely a new topic. But after cleansing the data, after transformation, after validation, after enrichment, and after, there will be a loading of the data into our database. Batch writes. We can't just call the database and say, this is the one product that I want to store. No, man. You're talking about the millions. You can't call your database write operation for like millions times. Just like batch them. Collect like 100 products and then ship it. Alright, let's take example. City A and City B. You want to send a courier from City A to your friend at City B. What you will do? Pass this pencil, then again courier this pencil, then this atomic habits book, and then this mobile. Instead of what you can do, you can make a container, and then you can wrap it and send it. And this is that have mentioned batch writes. Batch writes your database. You know the write operations are costly in the database. You want to save the cost. You're a good human. You're a good engineer. Okay. So uh, let's talk about this container. This container is basically, you can say, a magnifier to each worker's work and each salary task internals, what are happening inside the worker. And I have mentioned a robots.txt awareness. What is this? What is this? Connect the thing. You can't scrap anything. Scrapping can be legal, scrapping can be illegal. So every major website that knows we are being scrapped, and after the era, no, I'm not using the word after, during the era of generative AI, where the LLMs have their bots that go to your website's bots, they scrap the full website. Many websites wants, they don't want to share their data. So you can find the reports.txt file in major all of the website's home directory. So I'm taking the example of amazon.com/reports.txt. Here you go. This is the disallow. This is all right. What is this? Okay. Let me open again. Okay. They are allowing this. They are allowing the maybe the wish list, but they are disallowing this. So you have to check this. Otherwise, it is illegal. They can take action, and they should, because that's their data. All right. So they are blocking all the bots here: Perplexity, Claude, and GPT user. All right. Devin, that was there to enter software engineers, and all. You can see some are allowed and some are not allowed. Not allowed it. So you have to respect the robots.txt file in every scenario. If you are not, then some legal action can be applied to you. All right. So crawls listing page using Selenium. Selenium, what is Selenium? Selenium is just a browser automation tool. Okay. So you can say the Selenium, okay, go to this website, click to this book, scroll down, copy this and that. It's basically automation tool. And I will highly recommend you see, check the Selenium. You can automate your even boring task on the browser. If you're using anything, for example, sometimes I use my Chrome browser and any browser to start at a stopwatch, so I can just use the voice command, hey Chrome, set up a time watch or stopwatch. The Selenium will do all the work. Getting my point? So here I've mentioned a fan out design pattern. So fan out is this, this is a mobile. What will be fan out design pattern? That some operation, XYZ operation, happens on this mobile, and right now this is a single piece, it's an individual piece, and after that operation, this is further divided into multiple pieces. So this is what we call fan out, and the opposite is fan in. All right. So what is fan out? Go to my listing page. The listing page is only one. What is fan out? Finding the each product and going to each product page. So let me tell you here. This is a listing page. Many products are listed here. And then after some XYZ amount of time, one page, two page, three page, and then so on and forth, back and forth, 50 pages. So this is fan out design pattern. Then scrap each item page. First you scrap the listing page, now you scrap the list specific product page, and then you got the data. For example, the boys in the board, you got the data. This is the data you got. Now you have to do operations. You have to do the operations. Okay, for example, I want to like get this description. What can I do if so this is how you can access the, you can say, console, and you can say, all right, just my bad. We will actually looking in the source, but we don't have to look in the source that I was just explaining you. But you have to actually look onto your main web page. Like a very silly mistake, but it happens. So we can go here, and if we want to like get this description or this information, we can just like click on this, and then we, okay, no, there is a heading H2, okay, that have the title of product description, and this is the paragraph that I want to like get. Okay, So I want to okay, somehow access this data. Okay, so what can I do? I can see the HTML tree, and then I will try to, you can say, fetch the data. Okay, so this is the paragraph, this is the subheader, this is the table, if you can see here. Okay, and this is your t body and all the rows, and you can simply iterate over the table and fetch all data. So for example, this is the product description. Just copy the id, go to your console, and then now write here document dot query selector all. Alright, so you can pass this the ID, and the ID will come. And if there will be inner HTML, this is the inner text that is basically pointing to the heading of this. Or if you want to explicitly, because you want to get this description, click on this, and you can see there is no identifier for this paragraph, and there can be multiple paragraphs. So you can use simply your techniques. For example, what you can do, you can like document dot query selector all, and then you have to pass some identifier here. So analyze it. What can be the identifier? P does not have. Go to the P's. You can say P's parent. The P's parent is this article that have a class of product page, and then we have P. So go to product page, or it's a good practice to you can say hit the element using the id. So the id is content inner. Okay, so what I can do, hashtag content inner, content inner. So I got the id, but I want to go inside that. We can use this. If you know the basics of javascript, then you are probably knowing this. So we are here. Now we have to enter this article. We can say product page, and then we are you can say inside the product page, if I can show you, and we want to get this. All right, or we just have to give the class, or there is one article, we can simply say go to that article. Yes, here we go, and then we can say go to that paragraph. And if I go here, at index 0, this thing, and inner text, here you go, sir, this is your text. Cool. So this is how things work. You have to spend some time on the site, just like I did. But this is you how you got the your inner HTML if you want, and this is your inner text, and then do some simple data processing like remove the white spaces, and you are good to go by just writing one single query. Alright, so you must know JavaScript because browsers are JavaScript oriented. So this is how actually things work, and that's quite simple actually. And you can scrap all, and this code will be in your scrapper and crawler, and then we are simply scaling it. Coming back to this, so crawling is done, scrapping is done. Now you move the data to your ETL pipeline. First data is being cleansed out. Okay, cleansing is done, and then we do some data transformation. Just like the price is like 190k, 1,90,000, but you don't want the k. Okay, you want to do some operations of the on the price. So you just do your price of like you convert. I think a chart is better than explaining. So the price is like 190k, or let's simple take 1k, but you want to like do this to this, so you can easily do operations on the data. Obviously it will be in the integer format. So this is your you can say transformation. Then you validate the data. Sometimes or most of the times the data you are getting is not that you supposed. Might be you getting the price of -20, -290. You are not going to save this. Okay, so you have to reject this, and then you are doing some enrichment. How can I explain enrichment to you? All right, so for example, the enrichment can be something like this, that you get xyz amount of data from the product, but you want some initial data Okay, so data enrichment is basically this. For example, you get the, you can say, very simple example. There is a field on the websites of the each product that tells you on which date, month, and year you can say this product is being listed. So it's basically like January 10, 2010, or 19, or maybe whatsoever. So you can initially break this attribute into multiple attributes. This is what we call data enrichment. Okay, or if I can get some good example. All right. Basically, the thing I was able to explain you, data enrichment is the process of enhancing existing data by adding valuable information. Can you give us an example, brother? Uh, you just give us the example and we're good to go. Just give me examples. Just give me examples. Examples of data enrichment. All right. Geeks for geeks, please. You never disappoint me. Let's see. Uh, that's too much. Oh no, no man, no man. But basically, I described you the basic thing that you can like enhance the existing data by adding valuable information from internal and external sources. Okay, we are not going into that much depth of machine learning and that stuff. But this is how data enrichment is being done. Okay, coming back. We scrap each page we have done with this pipeline, and then simply this was the internal of the single task, and then we store the data into our database. So this is how the main, you can say, this scrapping platform is being worked. The scheduler beat is like a cron job. It basically acts as a scheduler. It pushes some tasks to your backend, to your broker. The workers are listening to the broker, to the queue specifically, and the all thing happens. And then you scale this. You add like 100 workers, 100 crawlers, and the scale is mass. The scale is mass. Okay, so this is thing. Let me explain you this thing as well. What if some task fails because you are not on your local? You are sending a request to the internet. You are doing network requests. You are doing some IO operations. You are talking with the database. You are doing a hell lot of options. Maybe something fails. So then you push the failed task into DLQ, dead letter queue, and then you can when you got time, you can see what went wrong. Okay, and DLQ is something like a task is being failed, push it to DLQ, and then after XYZ amount of time, try to redo the thing. If it again fail, push into DLQ2. Then after XYZ amount of time, try to redo. If it again fails, push that task into DLQ3. This is how things work. And like moving from DLQ2 to 3 just simply increases the time span. In DLQ2, it can be something like that. These are my failed tasks. You have to scrap this after 1 hour. It's failed, then it's again failed, push into DLQ3, and then say scrap it after 24 hours. And maybe if it's not scrapped, then there might be a problem on the website, and then we can simply discard it. But we must save the status, we must save the logs, because sometimes the problem is on our side. So this is how the overall things work. Let's wind up. Let's talk about the deployments. Basically, this is the project that I have developed is basically is in production. So I try to explain many myself. I try to explore many, you can say, topics in deployment. First, I created the mono code base. It contains your front end, your back end, your salary workers, your schedulers, your everything. Then there is a change detection, because obviously, if there is a change on just the API thing, you don't have to build the front end. And if there is change only on the front end thing, you don't have to like rerun your web server. So you must need a change detection. Lanes the code, test the code, because we are talking, we are in production. And if there is change in the backend, builds a Docker image on GitHub Actions. Okay, and not on GitHub Actions, obviously on the GitHub virtual machine that we can access using Actions. Then the push image to Docker Hub or any registry, and then pull that image on our VPS, the virtual private server, and then horizontally scale the salary workers. Getting my point? And if there is a change in our front end, builds the React code, copy static files to VPS, because at the end of the day, what is React? What is React doing? It's just doing some HTML, CSS, and JavaScript, and then serve the static files using Nginx. And here it's successfully live. This is how GitHub Actions actually saves a lot of time. You just do your git commit push and then workflow dispatch, and you're good to go. Talking about this, this is nothing. You have a lot of amount of data in your database and you want to do some crazy things on this. What you can do, use LangChain or any other tool. Just expose the schema of your database and your read-only access to the agent. Simple. And make a agent conversational UI just like the ChatGPT or Claude, and pass the query like I need an item in Los Angeles. The agent will try to convert this natural language query into SQL query, then run on database and then result. How's it? So you can say, I need a product in red color that's price is 120 and it's in Los Angeles. And you get the exact product from the scraping data. Okay, use this for just legal purposes. So this is how everything is working. I hope so that you have learned a lot from this. That was really a very quick and raw talk. Nothing cuts, nothing that type of things. Just like how we friends talk, how we software engineers talk. And this is how you can build an industry grade application. This is a great data engineering project, and this can shine on your resume. And thank you so much for watching. I hope so that you have learned. Safi out. Thank you.